Hi, welcome to another video in my series on the locus of a complex number. And in this video what I'm going to be looking at is the locus of a complex number which satisfies a particular inequality. And we're going to be shading the regions that represent these particular inequalities on an Argand diagram. And we start off with this first one, the mod of z minus all of 2 plus 3i being less than or equal to 3. Now, when we're doing these inequality questions, it's always a good idea just to replace them with an equal sign, just so that we familiarize ourselves with what that particular locus would be. So if this equaled 3, it represents a circle of radius 3 with center 2, 3. So it would look something like this if we were just to sketch it out on an Argand diagram. We've got our imaginary axis then, just label that on there, and our real axis here. And we've got the center of our circle at 2, 3, 2 across, 3 up. So we'll imagine that's the point then 2, 3. And because the radius of the circle would be 3, this circle would touch the real axis because we've got 3 units up here. Okay, now that's what it would be if it equaled 3. It'd be a circle, something like this. But being less than or equal to 3, we're looking for points within the circle. Now in question number 2, we've got the mod of z minus 3 being less than the mod of z minus 5. Now again, if it was an equals between here, then what we would have on the Argand diagram is the perpendicular bisector between the 2 points on the real axis, 3 and 5. So if I was just to finish sketching this off, we've got, say, 3 here on the real axis and 5 here on the real axis. So the perpendicular bisector would be a line coming down through here, passing through the 4. But it's not an equals, it's not even less than or equal to. So when it's either less than or greater than, you just have to draw a dotted line instead of a solid line. So what we would have here is a line coming up through here, dotted, going through 4 on the real axis. So we just mark that in as 4. So if it was equal, would be on the dotted line. But now it's less than in this example. So what we require is points to be closer to 3. Remember, this distance to 3 must be less than the distance to 5. So it must mean that we must be selecting points to the left of this dotted line so that they're closer to 3 than they are to 5. So we're going to get a region looking something like this. Now for question 3, we've got the arg of z minus 2 being between 0 and pi upon 4. In fact, it can actually equal 0 radians. So if this was an equal sign here, the arg of z minus 2 equals pi upon 4 radians, then that would be a half line. A half line starting on the real axis at the point 2, 0, say somewhere here. We'll just mark that in as 2. And this half line would go up at an angle of pi upon 4 radians. Now it's got to be less than pi upon 4 radians, so because it's not less than or equals to, it will be a dotted line. So if I was to draw a dotted line, something like that, that should represent that particular line, going up then at an angle of pi upon 4 radians. Now it's got to be less than pi upon 4 radians, but greater than or equal to 0 radians. And 0 radians would be the horizontal line here, and it could be solid, the real axis. So what we're looking at then is the region that's contained within the dotted line here and the positive real axis, something like this. Now in question 4, You might even like to try this. What we're looking for is a region that satisfies all three inequalities simultaneously. And it's basically following these ideas here. So why not pause the video at this stage and just see if you can do this one. Come back when ready and you can check your solution with mine. Okay, welcome back if you had a go. Well, what I would want to first of all do is set up my axes. So we've got the imaginary axis and we've got the real axis. Okay, so we need to start looking at drawing then each of these three inequalities. So for the first one here, this is our perpendicular bisector between the points on the real axis at -1 and at 5. So if we say that -1 is about here, okay, and we've got 5, let's say 5 is about here, then the midpoint between -1 and 5, if we were to add these two values together and divide by 2, that's going to give us 4 divided by 2 is 2. So we've got a point here, say at 2, and what we need to realize then is that this is greater than or equal to, so it's going to be a solid line as opposed to a dotted line. So if we mark that in, let's say it comes up here and we'll have it coming down here as well. Okay, now we've got to decide which side of the line we need to shade. Well, if we look at this as being the distance from any point to -1, and this is the distance from the same point to 5, then we want this distance to be greater than this distance. And clearly that's for any point on the right of this line here. If I had this point here, for instance, you can see that this distance to -1, okay, is much longer than it is to 5. So we need then to shade to the right of this line. Now I'm not going to do it at the moment on this diagram. What I'll do is I'll just record it up here. We'll have our real axis there and our imaginary axis, okay, and we've got our line coming down here and we want to the right of it. So that's what we'll be thinking of shading. Now we come on to this second inequality, the arg of z minus 1. It's got to be greater than or equal to 0 radians, but less than or equal to pi upon 3 radians. And so this represents a half line, okay? A half line starting at 1 on the real axis and then going up at an angle of pi upon 3 radians. And it's going to be a solid line because we've got less than or equal to here. So if we have, say, 1, let's just say it's here. It's not really drawn totally to scale, but it's just here to give you an idea. And we've got our half line going up at pi upon 3 radians. Let's say something like that, okay? And we want to shade the region that is greater than or equal to 0 radians, so that'd be along the real axis, a solid line there, and less than or equal to pi upon 3 radians. So it's going to be this region in here, okay? And again, I'll just record that up here, okay? We've got our imaginary axis, okay, and we've got our real axis, and we've got the line coming off like this. So we're interested in this area here. Okay. Now for the last one, the mod of z minus 4 less than or equal to 4. Well, if it equaled 4, it's going to be a circle with a radius of 4 and centre at 4. So let's say that this is 4 then. And if it's got a radius of 4, it's going to be a circle that touches the imaginary axis here. So if we were to draw that in, it's going to look something like this. Now, what we require is the area inside the circle, okay? So again, if we were to just sketch this out up here, real part, the imaginary part, and we've got a circle then coming round something like this. Okay, not a great circle, but we're interested then in the area inside the circle, okay, and including the boundary there. So if we need to have a situation where all three of these conditions are met, then we need to be then to the right of the line, okay, this vertical line, but at the same time inside this shape here and inside the circle. So the area that we want is contained in this boundary here. And if we shade it, it's going to look like this. Okay, well that brings us now to the end of this particular video, and I hope these examples will be able to give you some support when you're doing similar kind of things in other examples.